Hey everybody, welcome to Plains Overhead. And today in this video, we're going to talk about the GS Mini function of the Airbus A320. So it's a very helpful function actually, and we will realize it when you actually do, line flying. So GS Mini, the purpose of GS Mini is to take advantage of the aircraft inertia when the wind conditions vary during the approach. So it's important to know that GS Mini function is activated during the approach only. With this, what happens is the energy of the aircraft is maintained above a minimum level, so it provides a standard aerodynamic margin versus stall. Okay, so you do not stall during the approach phase, especially the crucial landing phase. So the minimum energy level is represented by the ground speed that the aircraft will have at touchdown. So this ground speed is actually called GS mini. So the ground speed that corresponds to minimum energy level at touchdown is your GS mini. Okay, so before we actually step into GS mini, I want you to know some definitions. What is star wind? It is the magnetic wind entered in the performance approach page. It is the average wind as provided by the ATIS or the TAR controller. Gusts may not be included in this, they are included in the ground speed mini calculation. What is star headwind component? So obviously whatever the reported winds are, the headwind component of that is your TAR headwind component, and it is used to compute V approach in GS mini. Current headwind component, now this is something interesting, it is taken out from the ADIRS, which is the instantaneous headwind at that point in time. And this is very important because it is the one that computes the variable IS speed target. I mean, this is what is used to compute the variable IS speed target. Okay, so current headwind component is also understood. Now, what are GS Mini features? The GS Mini ensures efficient thrust management during approach with respect to gusts or longitudinal shears. So it has efficient thrust management which varies between plus to minus 15% N1 range from a particular setting during approach. Okay, so what happens is there's not sudden rise in thrust, decrease in thrust just because of gust or longitudinal shears. The speed target is displayed in magenta when approach phase and managed speed are active. Very important line, that's why it's in bold. Approach phase and managed speed are active. Another very crucial thing that people actually get confused with is GS Mini is actually independent of autopilot, FDs, and or auto thrust engagement. So it doesn't absolutely matter whether your auto thrust is on, your autopilot is there, or FD is there, doesn't matter. It is a speed target which is displayed in magenta when your approach phase from the MCDU is activated and the speed is managed. Okay, so these are the two important features. Nothing to do with auto thrust, nothing to do with autopilot, nothing to do with FDs. So how do we know what's happening? When the speed target goes up, you should know that it's a headwind gust. Okay, because the aircraft is trying to maintain a ground speed to maintain an energy level. Wind is a very key factor in the GS mini function. Most important point, GS mini is not displayed to the flight crew. We do not have any indication on the PFD to know what is the GS mini. We can only have a calculation done basis on the approach speed. So before we actually step into GS mini computation, I want you to know how V approach is calculated. So V approach is either the two of these, whichever the highest. So V approach is VLS plus 1/3 of the TAR headwind component, or VLS plus 5 knots, whichever is the highest. Okay, so suppose the TAR component is tower headwind component is say 30 knots, so 1/3 of that is 10. So VLS plus 10 will become your V approach because VLS plus 5 is just 5. So whichever is highest. Now 1/3 of the TAR headwind component has two limits. 0 knot is the minimum value. So 0 is the minimum value, that is node wind or tailwind, and plus 15 as the maximum value. So 1/3, that basically means TAR headwind component has to be 45. So that's like the maximum limit. So 1/3 of the tower headwind component has two limits. Anyway, all this is just for your knowledge. It's not really, it is all automatically done by the the FMGC. The flight crew can manually obviously modify the V approach and the tower wind values on the performance approach page. Okay, so that's how the V approach is calculated on the MCDU performance page. Now the speed target computation, very important for us, which is displayed on the PFT as a magenta, this thing, triangle. The FMGC continuously computes a speed target, which is the IS target, that is the MCDU V approach value plus an additional variable gust. Okay, very important. MCDU approach value plus an additional variable gust. The gust is instantaneous difference between the current headwind component and the tower headwind component. It is always positive or equal to 0 for no wind or tailwind. So your headwind the gust is an instantaneous difference. Current headwind comes from the ADIRS. So the tower headwind is obviously given in the MCDU. So it is the difference between the current headwind and the tower headwind. Okay, and it's always positive, because if it is negative, it is understood that it is tailwind. So that is not considered. So the gust is always positive, and it is equal to 0 if it is no wind condition or if it's a tailwind. Okay, so there's no gust from the tailwind conditions. So IS target is then V approach plus current headwind minus the tower headwind. So that's the formula for the IS target that's displayed on your PFD. V approach plus the current headwind, that is the current headwind, the instantaneous headwind that is coming from the ADIRS, minus the tower headwind component. Now this IS has two limits again. V approach is the minimum value, and VFE minus 5 in config full, or VFE of the next config in the other config. Anyway, this is not really important for us to know. Okay, so this is important to know. Now comes the most important, GS mini computation. Now GS mini is V approach minus tower headwind component. Okay, so whatever your V approach is calculated minus the tower headwind component is your GS mini. So that is like the minimum ground speed that the aircraft will maintain to have a constant efficient energy level. The aircraft ground speed should never drop below the GS mini in the approach while winds are changing. Okay, so that's the minimum ground speed that has to be maintained. Thus, the aircraft IS must vary in order to cope up with the gust and wind changes to maintain a constant ground speed. Now, the FMGC computes a IS value which ensures that GS is the ground speed of the aircraft is always greater than GS mini. So the FMGC is giving the the PFD a value IS target that is always ensuring that the ground speed of the aircraft current ground speed is always greater than the GS mini. So because mini is the minimum speed that the aircraft has to maintain during approach to accommodate for your energy efficient energy. Okay, and that IS target is GS mini plus the current headwind component. Okay, so the IS target that's displayed is the GS mini, which is obviously V approach minus tower headwind component plus the current headwind component. So this is how your IS target is done. Now you will understand this pretty clear with the example actually. So if you have not understood anything on the previous few slides, you just come down here. It's pretty simple. So suppose the VLS of the aircraft is 130 knots for the certain, configurations or whatever from the FMGC you picked up 130 knots. Now tower wind is reported 20 knots headwind. Just for easy example, tower wind is straight 20 knots. So what becomes your V approach is 130 plus one third of headwind. So one third of 20 is approximately we're taking 7. So 130 plus 7, 137 knots. So that is your V approach speed. Now GS mini is V approach minus the headwind component. Okay, tower headwind component. So 137 minus 20 straight away. So that gives us a GS mini of 117. Now the point is the aircraft has to maintain a minimum of 117 ground speed during the approach to accommodate all the gust variation and everything to have an efficient energy level. So now point A, when there is 20 knots headwind. So V approach is the IS target, ground speed equal to ground speed mini, because 20 knots headwind we already had subtracted, so it is maintaining the ground speed. Okay, so GS is 117. GS mini is equal to the ground speed mini. So it's all good. Now what happens is suddenly a gust of 40 knots headwind. Okay, that's in point B. Now what happens in point B? There's a headwind gust. The IS target increases. The IS increases, the GS mini is maintained because the ground speed is maintained because you've got a certain headwind. So the aircraft analyzes the GS mini that it is 117. So but there's a strong headwind, so it has to increase thrust. So thrust slightly increases. Okay, so then your ground speed is maintained. Now suddenly during the same approach, suddenly the aircraft loses the headwind and then you have suddenly tailwinds hitting you. So now what happens is the IS target decreases, but it is minimum at V approach. It will not go below V approach. Okay. IS decreases, the ground speed increases because suddenly from headwind it's become tailwind. So your ground speed will actually increase. Thrust slightly decreases, of course, because you're having tailwind. So to use the aircraft inertia to get in, thrust is slightly decreased. And then your ground speed is increased due to the tailwind, and the GS mini is anyway maintained because GS mini is the minimum speed. So the ground speed is little more, is still okay. So the aircraft can be controlled well. So what happens is the whole point of crux of GS Mini is that the power is adjusted to accommodate all the gusts and everything. So the pilot really doesn't have to concentrate on the winds directly. The aircraft is computing itself a certain speed IS target that it will maintain to keep a constant energy efficient level all the way through till touchdown. Okay, so I hope you have understood GS Mini, and thank you for watching, guys. Subscribe to the YouTube channel and like the Facebook page for regular updates. Give the video a thumbs up if you like this video, and please share it too. Comment below if you have any doubts. I will surely get back. You can always contact me on these links mentioned on your screen. Cheers and happy landings, guys. Have a great day. Take care. Bye bye.